So, you've spent months, maybe even years, building this incredible application on the blockchain. It's smart, it's innovative, and it's almost ready for users with real money on the line. But here's the thing. In this world, one tiny little mistake can bring the entire thing crashing down. So, how do you protect your creation? How do you protect your users? Well, let's break down the playbook for building apps that are truly unbreachable. Just think about that for a second. In our normal digital lives, we've got a safety net, right? There's an undo button, a password reset link, a friendly support agent who can help us out. But on the blockchain, that net is just gone. Every single transaction is final, it's public, and it's a permanent mark on the ledger. And this slide really nails the difference. Over on the left, you've got the world we're all used to, the forgiving world of traditional apps, where we can fix things. But on the right, well, that's the blockchain reality. Transactions you can't take back, permanent loss if something goes wrong, and a public record of everything. This is exactly why, on the blockchain, security isn't just some feature you tack on at the end. It's the very ground you have to build on from day one. So where do we even begin? Well, it all starts with the keys. If you think of your app as this high-security bank vault, then your first and most important job is to be the world's strictest, most paranoid gatekeeper. So welcome to Act 1, securing the keys. This is it. This is the single most important rule in all of Stellar development. I want you to burn this into your brain. If an attacker ever finds a user's secret key on your server, their wallet is going to be drained. Instantly. Permanently. There is no undo. There's no getting it back. Game over. So how do we actually follow that number one rule? We do it with a workflow that looks just like this, using a wallet like Freighter. Your app creates the transaction, sure, but then it hands it off and just requests a signature. The user sees exactly what they're signing, they approve it in their own secure space, and only the signed transaction ever comes back to you. The key takeaway? Their secret key never touches your server. Not for a second, not ever. Now, the same logic applies to your own backend keys too. I mean, you wouldn't use one master key for every single door in a bank, would you? Of course not. And you shouldn't do it here either. You use different keys for different jobs. The issuer key, the one that can literally print new tokens, lives completely offline in cold storage. The distributor key is online but just to send tokens out, and your hot wallet for daily stuff has the smallest balance possible. That way, if one key gets compromised, the damage is contained. Okay, so the gates are secure. We've got our gatekeeper. But what about the walls of the vault itself? Now we need to make sure the code is structurally sound. And that brings us to Act 2, writing unbreakable code. Your smart contract has some really powerful functions, ones that can move money or change who owns what. I want you to think of require auth as the big, tough bouncer standing at the door of every single one of those functions. His only job is to check the ID of whoever is trying to get in. If you forget to put this bouncer on duty, literally anyone can just waltz right in. Forgetting this is like leaving the vault door wide open with a giant help yourself sign on it. Here is a classic, really sneaky vulnerability, the integer overflow. It's this weird bug where a number gets so big that it wraps all the way back around to 0, kind of like an old car's odometer. On the left, a simple addition could trigger this, and that could potentially let an attacker mint infinite tokens. But look at the fix on the right. It's so simple. Using a checked add function makes the math totally safe. If it detects an overflow is about to happen, the whole transaction just fails. Catastrophe averted. Now here's a modern pro tip that is an absolute game changer. You can treat an AI assistant like your own dedicated security partner. Feature code and literally ask it to play offense. Tell it to hunt for the exact vulnerabilities we're talking about right now. It's like having a security expert on your team who never sleeps and never gets tired, working for you 24/7. Bulletproof code is fantastic, but you know what? It's only half the battle. How you actually manage and deploy that code is just as critical. So that brings us to Act 3, the operational playbook. These are the essential rituals you have to follow to keep your project safe out there in the wild. Every developer lives in two different worlds. On the left, you've got testnet. It's a safe, friendly sandbox. You get free money from a faucet, mistakes cost absolutely nothing, and you can experiment all you want. But then on the right is mainnet, and that's the real world. We're talking real money, real stakes, and mistakes that can be totally devastating and permanent. The rule here is simple. You have to live and breathe on testnet until your application is absolutely, positively flawless.
All right, here are two simple but incredibly powerful rules for every single transaction you build. First, always set time bounds. This basically gives the transaction an expiration date. Without it, someone could hold on to it and submit it weeks from now when the market conditions are totally different. Second, for smart contracts, always run a simulation first. It's a free, dry run that tells you ahead of time if the transaction is going to work, which prevents you and your users from wasting fees on calls that were destined to fail anyway. All right. The keys are secure, the code is solid, and our operational playbook is defined. There is just one last ritual left before you launch. It is time for the final inspection.
So let's run through the checklist, rapid fire. Are your own secret keys completely scrubbed from your code and your Git history? Check. Are you using a wallet like Freighter so you never ever touch user keys? Check. Are you validating every single piece of user input so you don't get garbage in, disaster out? Check. And does every critical function have its require auth bouncer on duty? Absolutely. Check.
And we're not done. Is all your math protected from those sneaky overflow bugs? Check. Do all your transactions have an expiration date, and are you simulating your smart contract calls to avoid failed fees? Check. Has your app been battle tested on testnet until it is begging for mercy? Check. And finally, are your monitoring alerts all set up so you know the second something looks even a little bit suspicious? Check. Because when you boil it all down, all of this, every line of code, every security process, every single checklist item, it all comes down to just one thing: trust. In a world where there are no second chances, trust is the only currency that really matters. You've built the vault. The real question is, have you earned their trust?